Okay, so let us start with the lecture. So backface removal is the first method to remove the hidden surfaces. In this method, this method actually is based on the object space method that we have already learned. It is object space method, and it determines the hidden and visible surfaces depending upon in-out test. So whether the point or whether the surface lies inside or outside, depending upon that test, the um, decision is made whether the face is visible or hidden. Okay, so we were observing this point. So if a point xyz is inside a polygon surface with a plane parameters a, b, c, and d. So a, b, c, d are the constant parameters, and with a polyhedron we are having the expression as uh, ax plus by plus cz. So we have already seen this expression, ax plus by plus cz plus d equal to 0. So that is the expression for the polyhedron, where x, y, z are the coordinates of the point, and a, b, c, d are the constant, plane constant, we can say. So if when a inside point is when any point P is considered as inside, then suppose point P is inside this surface. This is your point P. If it is inside, it means this value ax plus by plus cz plus d should be less than equal to 0. This value should be less than equal to 0. Then it is considered as the point is inside. If this point is if this value is greater than 0, then we are going to consider that point as backside point. That is nothing but it is not inside, which is available for visible faces. So that is the test considered, and for this test we are going to consider a normal vector from this P point. So a normal vector for this surface. So consider this rectangular surface, and this point is P with x, y, z as the coordinates. When I am drawing a normal vector means for this surface I am drawing a perpendicular. So this is the surface, this is your surface which is in xy plane, and you are drawing a normal vector along the z direction. So from this point I am drawing a normal vector, and it is considered as the n. So it is holding the value equal to n. So it is tested with a simple test that if the direction of the normal and the direction of a viewer, so if this viewer is viewing from this side, so if the direction of normal and direction of viewer, in those directions, if the angle between those directions is more than 90 degree, then the face is visible. Then the face is visible, else the face is not visible or it is hidden. So what is the meaning? So see here, the viewer is at this location and it is viewing the object. So this is the object viewer is viewing, and the normal is drawn from this point P, which is facing towards the viewer. So if I am going to draw these two lines or two directions, so this is the direction of viewing and this is the direction of normal vector. So they are exactly opposite to each other, and the angle between them is 180 degree. The angle between them is 180 degrees. So what our calculation tells us? The calculation tells us that if the angle between V and N, if the angle between V and N is greater than 90 degree, then that face is visible. So if the angle is greater than 90 degree, then the surface is visible. And if it is less than 90 degree, then the surface is not visible. For example, if you consider this backside point, the point which is lying suppose on this surface, backside surface, and I am going to draw a normal with that surface. So normal to this surface is like this, which is pointing away from the user, right? So बॅकसाईडचा सरफेस आहे, त्याच्यावरचा एक पॉइंट घेऊन जर मी त्या सरफेसला नॉर्मल काढली, सो इट इज द बॅकसाईड सरफेस आय हॅव ड्रॉन विथ द डॉटेड लाईन्स. This backside surface has a point and a normal is drawn. Normal ती असेल Z डायरेक्शन मध्येच असेल, कारण हा परत तुमचा XY प्लेन झालं, and the normal is in the Z direction. But now if viewer is on the same side, the viewer इथेच आहे, and you have got this normal which is pointing away from the user. So if I will draw this viewer's direction and the direction of normal, so I can say the viewer is viewing in this direction and normal is also in the same direction. Now what is the angle between these two? As both are having the same direction, the angle is 0 degree. The angle is 0 degree. So I can say the angle is less than 90, and that's why the surface is hidden. Getting the difference between these two? The surface we are taking, and by considering any point on the surface, I am drawing a normal to that surface. If the viewing direction and normal direction, the angle between these two is greater than 90, then the surface is visible. And if this viewing direction and the normal direction is having the angle less than 90, then the surface is hidden. So we can have another example. Like if I am taking this particular side, and I am drawing a normal to this side. So normal is like this. Now what is the direction between these two? So viewer is in this direction. So I am drawing the diagram. This is the direction of a viewer and the direction of a normal. So this is your normal and this is your viewer. So again the angle is more than 90 degrees. So 90 degrees this angle, and the angle between these two is more than 90. That's why this face will become visible as viewer is in this side. Viewer is in this side, so this surface will also become visible. On the contrary, if I am having this particular surface and normal drawn is like this. So now I will draw a diagram of normal with a viewer direction. So this is your V and N. Now what is the angle between V and N? It is less than 90. So according to our assumption, if angle is greater than 90, then the surface become visible in this case. So according to the viewer, this surface is visible. The front surface is visible. And the top surface is visible because the angle between this one and the top so angle between the viewer and the top, so from viewer to top you are having this angle, so it is greater than 90 degree, and that is why as angle is greater than 90, this face is visible with respect to the user. And the backside faces, this one, the bottom one, and this face, these three faces will become invisible or hidden. Getting it? All of you? Yes, students?
Yes,
Or
ma'am.
shall I? Okay. Boys side?
Yes, ma'am.
Okay. So it is very simple test because just we need to check the direction and the angle between these two direction. So that's why this test is a faster and simpler one. And it is depending upon the object space method, because actually we are concentrating on the object and its physical coordinate system, because x, y, z are considered as physical coordinates of this object, and the normal is also considered as physical coordinate, and that's why it is the object space method, and it is considering the inside outside test. So it is checking whether the point is inside if this expression is true, and on that point we are drawing the normal and checking the direction and angle between them. So this is the very simple method of all the methods. So it is only specified here with the help of uh, angle and all these characteristics. So it is actually not required, because in earlier this dot product, what this dot product saying, if v dot n is greater than 0, so dot product gives you vn cos theta, so cos of angle between them. So ultimately it is going to consider the angle between v and n. So depending upon that angle, it is tested whether the uh, side is visible or not. Now what will be the drawbacks of this method? So it only caters for non-overlapping polyhedral. So I have taken the example of a simple cube. So it is non-overlapping polyhedral. For example, let us see this particular diagram. Okay. Now these two surfaces, or these two objects rather, they are overlapping, right? This smaller object is overlapping the bigger object. So for such type of examples, our backface removal detection algorithm will not work, because it determines the face as a whole. So it is going to determine about this face, the bigger face which is attached to the smaller one. ह्या bigger face तो detection करेल. It will consider this point which is inside. So for this point P, if I will draw the normal vector and viewer is viewing from this direction, then I will say the whole face is visible. But it is not the case, because the whole face is not visible, only this portion is visible, right? Only this portion is visible. The whole face is not visible. Why? Due to this overlapping object. So these overlapping conditions are not treated well in backface removal method, right? So it only caters well for non-overlapping convex polyhedral. So convex polyhedral means what? Concave and convex, two types are there. For other cases where there are convex polyhedron or overlapping objects, we still need to apply other methods for further determination of the hidden and visible surfaces. So in such examples where the objects are overlapping each other, we cannot use this method. That is the first drawback. And second is, it is not applicable for partial visible surfaces. The example is this. So if you see this surface, which is actually backside surface, a larger portion of it is on the back side. But only small portion is visible. But according to our algorithm, we are going to consider the whole face, either it is visible or it is not visible. So for partial visible surfaces, this algorithm is not working. Okay, so these are the two drawbacks of the method back face removal. All of you are getting it?
Yes, ma'am.
Okay, so to deal with such examples of overlapping polygons, we are going to learn the second method, which is called as Z buffer algorithm. So Penter's algorithm that we will see afterwards. First, we will cover this Z buffer algorithm. So Z buffer, it gives you idea with the name itself that it stores the Z values of every pixel rather. Right? So this object is comprised of number of pixels, and all pixels Z value it is going to store in some buffer. So I am using some buffer in which I am storing the Z coordinate of every point. So this is first point, the second point, third point, fourth point, fifth point, and so on. So all the Z values are stored in this, and that's why the name is given as Z buffer. So Z values are stored in this buffer. Now it uses two buffers actually. One is to store the Z value and other buffer is used to store the intensity at that point. Okay, so two memory areas are used or two buffers are used in which one is storing the Z coordinate and the other is storing the intensity at that Z coordinate. Suppose for this particular pixel, for this corner pixel, suppose the Z value is 5. Suppose the Z value is 5. So it will store at 5 Z value. What is the color intensity? So whatever is there for blue color, it will store that intensity here. Suppose the blue color value is 3. So it will store 3 in this buffer. So at a time, I am going to store its Z value and the color of that pixel at Z equal to 5. Okay, so it is used for storing the two things, the Z coordinate and intensity at that Z coordinate. This algorithm is also called as depth buffer algorithm. Depth means what? Because we are concentrating on the Z parameter. We are considering the X parameter as the length. We are considering the Y parameter as height. And we are considering the Z parameter as breadth, or it is also called as depth. And as we are storing the Z value, that is depth value of the object, and that's why the name is given as depth buffer algorithm. Okay. This approach compares surface depth at each pixel position on the projection plane. So what it does basically, consider I am having a object like this, an object like this. Okay. This point, which is on the back side, is acting as the origin. This point is acting as the origin. Okay. This point is acting as the origin. So origin means what? Its coordinates are 0, 0, 0. X value 0, Y value 0, and Z value is also 0. Now on this line, if I consider this particular line, on this line, which point is visible? This whole line is dotted line, isn't it? This whole line is a dotted line. So on this line, which point is visible? This point, a corner pixel, which is having maximum Z value. Right? Because Z value at the origin is 0. As soon as I move along this Z axis, as this is origin, this line gives me the Z axis only. So as I will move along this Z axis, Z value will go on increasing. Z value at this point will become 1. Then at this point, it will become 2, 3, 4. And at this corner pixel, the Z value will become 5. All of you agree with this?
Yes, ma'am.
Okay. So at origin, coordinates are 0, 0, 0. And at this particular point, what are the coordinates of this corner pixel? XY are still 0, 0. But Z value is equal to 5 because it is lying on the Z axis. That's why X and Y are 0, 0. But Z value is 5. Now, what makes the point to be visible? Point becomes visible because it has the larger Z parameter. Maximum Z value keeping X and Y constant. X आणि Y कॉन्स्टंट ठेवले आणि Z चेंज करत गेलं. Z इथे पण चेंज झालाय 1 ला, 2 ला, 3 ला, पण स्टिल 1, 2, 3 हे विजिबल आहेत का? नाहीयेत. Z equal to 5 हा पॉइंट विजिबल आहे बिकॉज इट इज हॅव्हिंग द मॅक्सिमम ऑफ Z व्हॅल्यू. So by keeping X and Y constant, I will check the maximum value of Z and that is considered as visible point. आणि मग मला कळलं की हा Z equal to 5 हा point visible आहे. So I will store Z equal to 5 over here. And if that color of that pixel is blue, then I will put here blue color and store that intensity in the intensity buffer. Okay. So in this way, for every pixel, I will check the maximum Z by keeping X and Y fixed. By keeping X and Y fixed. So whatever may be the maximum value of Z, those points are only visible. So every time I am going to compare each pixel with its Z value. प्रत्येक पिक्सेल मी कंपेअर करणार आहे दुसऱ्या बरोबर for getting the maximum Z value, and that is the flow of this algorithm. So let us read it line by line. This approach compares surface depth at each pixel position on the projection plane. So projection is along Z axis. So for every pixel, it is going to compare the depths. Depth means Z value. Object depth is usually measured from the view plane along the Z-axis of a viewing system. So always this measurement is done along Z-axis. This method requires two buffers. One is the image buffer and other is called Z buffer, or it is also called as depth buffer. Each of these buffers have same resolution as the image to be captured. So they are having the same resolution according to the capture of the image. Whatever we want to display on the output screen, the same type of resolution is there for these buffers also. As surfaces are processed, the image buffer is used to store the color values. What we are going to store in the image buffer or intensity buffer? Here we are going to store the color values, that is the intensity of that pixel, of each pixel position. And in the Z buffer, it is used to store the depth value for each X comma Y position. So X comma Y is 0, 0. For this also X comma Y is 0, 0. And for this also X comma Y is 0, 0. So for 0, 0, it will store the depth value of every pixel. So it will store 0, 1, 2, 3, 4, 5. and maximum Z value is used for the display purpose. So you can see here now. So if now overlapping surfaces are there, now what is happening? S1, S2 आणि S3 हे 3 overlapping surfaces आहेत. बरोबर? So on, if I am considering those overlapping surfaces and a line where x, y is a fixed value. या सगळ्या पॉइंट्स x, y सेम आहे. फक्त चेंज काय होतंय? Z, कारण Z व्हॅल्यूज चेंज होतीये इथे. Z इन्क्रीज होतोय. Okay, so here I am having the view plane position x, y. X, y fixed. Surfaces S1 had smallest depth. S1 ची depth किती आहे? Smallest आहे. Then it has S2's depth and then it has S3. So I can say this is having the minus some value. If this is your positive Z axis, I can say on the opposite side means towards negative Z axis. So if this S3 is having suppose minus 10 Z value, then this S2 is having suppose minus 5 Z value and S1 is having suppose minus 2 Z value. That means larger is the value with XY constant, obviously. X and Y we are keeping constant. And the maximum GZ value असेल, that is going to consider for display purpose. So I am going to display this point. So suppose this surface is of red color. हा point red color चा होता. This point is of blue color. And the third point suppose is of black color. So it will check the Z value of every point with x, y and maximum value G असेल -2, that will be used for the display purpose. So -2 is the value is getting stored in the Z buffer and black color is getting stored at the image buffer. So what is the meaning? At x, y, z, you have to put this value -2, which is visible, and you have to put a pixel with black intensity. Though on the same line, I have 3 colors. Yet same line varti 3 color आहेत, red, blue, and black. But why I am displaying black color? Because its depth is less. It is towards the viewer. So viewer च्या जवळ आहे. Suppose I am having this object. So if this pixel I am going to consider, this pixel is part of this square also and it is the part of the triangle also. हा पिक्सेल आहे तो स्क्वेअरचा पण पार्ट आहे आणि त्या पाठीमागच्या ट्रायंगलचा पण पार्ट आहे. पण तुम्ही कुठला पिक्सेल डिस्प्ले करणार? स्क्वेअरच्या कलरचा का ट्रायंगलच्या कलरचा? सो स्क्वेअर इज मोर नियर सपोज, जर स्क्वेअर जास्त जवळ असेल युजरच्या तर स्क्वेअरच्या कलरचा डिस्प्ले होईल आणि जर ट्रायंगल जास्त जवळ असेल, स्क्वेअर बॅक साइडला असेल तर ट्रायंगलच्या कलरचा तो डिस्प्ले होईल. So depending upon the depth, you are going to set the color and the Z value in Z buffer as well as image buffer. Getting it, all of you? Yes, girls?
Yes, ma'am.
Okay, boys side?
Yes, ma'am.
Yes. So here it is considered as the Z parameter and depth is nothing but smallest depth with respect to user. User is viewing from this direction. So whatever the object which is closer to the viewer, that will be displayed. That intensity will be displayed first. Okay, so that is called as depth. Okay. So now let us learn the algorithm. So initially each pixel of Z buffer is set to maximum depth value. Depth value maximum means background च्या साइडचं जे color असेल तो. On this plane, suppose I am having the object. Suppose I am having this object. So maximum depth from user side means this is user side. Maximum depth means जे सगळ्यात लांब आहे. लांब काय तर background आहे. So background is the farthest visible part. So first काय करणार आहे मी Z buffer ला सेट करणार आहे मॅक्सिमम व्हॅल्यू डेप्थ ची. सो डेप्थ ची मॅक्सिमम व्हॅल्यू म्हणजे काय तर मे बी -1000 we will set. Depth buffer I am going to store -1000, that is towards negative Z axis, and which is your background pixels, and its intensity I am going to store. Image buffer is set to background color. So intensity च्या मध्ये मी काय करणार आहे background चा color set करणार आहे पहिल्यांदा. BK stands for background color. Okay, आणि त्याच्यानंतर मात्र every pixel I will compare with background. जर तो पिक्सेल पुढे असेल युजरच्या जवळ असेल, so according to that the negative 1000 पेक्षा जर त्याची व्हॅल्यू जास्त असेल, that means towards user असेल, तर I am going to replace this by that pixel and so on. Okay, so let us start. Surfaces are rendered one at a time. So surfaces we are going to process one at a time. Rendering means processing. So this is your origin, suppose. Surfaces are rendered one at a time. For the first surface, the depth value of each pixel is calculated. So consider now for origin. So for this origin, Z value is 0. So it will compare between 0 and -1000. So now this 0 pixel is 0 value is greater than -1000. So I will remove this and I will store 0 over here in the algorithm, in the buffer, Z buffer. And intensity of that 0 I will store as, suppose this pixel is of red color. So I will store here intensity equal to red. That is whatever integer present for red. Then if this depth value is smaller than the corresponding depth value in the Z, that is closer to the viewer, so both values are replaced by the new points. That is what we have done. So earlier background ची value होती -1000. Whether 0 is less than 0 is greater than this -1000, that is towards viewer. So if it is true, then we are going to replace that Z value by 0 and replace the intensity by that 0, 0, 0 intensity. So the intensity at that point. Repeat this step for remaining surfaces. So again, I will repeat for remaining surfaces. So this is the surface. Backside च्या surface साठी मी आता calculate केलं ज्याची व्हॅल्यू होती Z ची 0. त्याच्या पुढचा मी एक सरफेस घेणार आहे. त्याच्या पुढचा सरफेस कुठे असणार आहे इथे ग्रीन कलरचा, which has the Z value equal to 1. त्याच्या पुढचा सरफेसेस just consider as different layers of this object. लेअर वाईज कन्सिडर करा. हा बॅक साइडचा लेअर होता रेड कलरचा, त्याच्यात जस्ट पुढचा लेअर आहे जो आहे ग्रीन कलरचा, जिथे झेड व्हॅल्यू आहे 1. नाव इट विल कम्पेअर 0 विथ 1. 0 जास्त मोठा आहे का 1 जास्त मोठा आहे विथ रिस्पेक्ट टू व्ह्युअर? So 1 is greater. So I will replace this 0. I will put here 1 and intensity also red will be removed and green will be stored. आता मी त्याच्यामध्ये ग्रीन इंटेन्सिटी स्टोअर केली. सेम वे मी पुढे आल्यानंतर सपोज माझ्याकडे ब्लू कलरचा एक सरफेस मिळाला मला, which has your z value is equal to 2 and color equal to blue. So 1 will be replaced, it will be stored as 2 and green will be replaced and I am going to store blue color over here. And at the end I will find the maximum value is there for this surface which is having the black color in it. म्हणजे सगळ्यात पुढचा सरफेस लेअर मधला कुठला आहे? ब्लॅक कलरचा सरफेस आहे. सो आय विल रिप्लेस दिस 2 value by 5 where z value is 5 and the color is black. Okay, so I am going to store the black color over here. So this black color I am going to reflect in the intensity buffer. Getting it? So for every surface in a layer wise, for each pixel on that surface, फक्त एकाच पिक्सेल साठी नाही, असे सगळे पिक्सेल्स जे त्या सरफेस वरती आहेत त्या सगळ्या पिक्सेल साठी मी सेम फंक्शन कॅरी आउट करणार आहे. So after all the surfaces have been processed, each pixel of the image buffer represents the color of visible surface at that pixel. मग जे काय माझ्याकडे बफर मध्ये स्टोअर असेल तर x00 ला 5 हा पॉइंट व्हिजिबल आहे. त्याच्यानंतर x ची व्हॅल्यू जेव्हा 0,1 असेल तेव्हा मे बी 4 नंबरचा पॉइंट व्हिजिबल असेल. सो इन माय बफर आय विल हॅव द लिस्ट ऑफ द पिक्सेल्स विच आर व्हिजिबल विथ रिस्पेक्ट टू द युजर. त्याची झेड व्हॅल्यू सगळ्यात मॅक्सिमम असणार आहे. सो दोज पिक्सेल्स आर ओनली व्हिजिबल. Okay, so that is the Z buffer algorithm. Now, whether the drawbacks of earlier methods are overcome here. आता बघूया, हा ड्रॉबॅक होता आपला, ओव्हरलॅपिंग सर्फेसेस आपले बॅकफेस मध्ये नव्हते डिटेक्ट होत, पण ह्याच्यात होणार का? होणार, कारण याच लाईन वरती जर झेड बफरची झेडची व्हॅल्यू जी अर्लियर व्हॅल्यू असेल. ओके, सो पहिल्यांदा मी काय करेन, हा पॉइंट जो एक्झिस्टन्स मध्ये आहे त्याची झेड व्हॅल्यू स्टोअर करेल, त्याची इंटेन्सिटी. तसंच पुढे येत येत सरफेस मध्ये काय होईल, माझ्याकडे हा जो पॉइंट आहे त्याची झेड व्हॅल्यू डिस्प्ले होईल. तसंच आता या लाईनवर काय होईल, या लाईनवर याच्या एक्स अँड वाय साठी पहिल्यांदा ही व्हॅल्यू डिस्प्ले होईल, पण जेव्हा झेड इन्क्रीज होईल तेव्हा मॅक्सिमम झेड व्हॅल्यू अलॉंग दिस एक्स कॉमा वाय, या एक्स कॉमा वाय साठी मॅक्सिमम झेड व्हॅल्यू कुठली आहे, या ब्लॅक पॉइंटची. सो इट विल गेट डिस्प्लेड अलॉंग दिस लाईन. मॅक्सिमम झेड व्हॅल्यू इज दिस, बट इफ आय एम कन्सिडरिंग दिस पर्टिक्युलर लाईन, आता मला ही एक लाईन माहित बघायची आहे, तर या लाईन मध्ये काय होईल, हा पाठीमागचा जो पोर्शन आहे मोठ्या बॉक्सचा, दॅट ऑल पिक्सेल विल बी हिडन. Only the pixel of the smaller object, this corner pixel is visible along this line. So on this line, I have compared all pixels of big box and small box because X and Y values are same throughout this line. Throughout this line, X and Y values are same, and that's why I am judging this maximum value of Z, and that is only the visible value. Okay, now what happens with the smaller box? या smaller box मध्ये काय आहे, तर on this line I will be checking the whole line, but for the bigger box on this line I will be checking x comma y values, keeping x comma y fixed. The maximum z on this line present is this, and that's why it will display you properly the visible and invisible faces. Getting it, all of you?
Yes, ma'am.
Okay, girls.
Yes, ma'am.
Okay, so आता जरी overlapping असेल तरी काय होईल? I can detect which faces are visible. or समजा overlapping जरी नसेल आणि आपण मगाशी बघितलं होतं दुसरा ड्रॉबॅक या फेसेस साठी सुद्धा या फेसेस साठी काय होईल? Here also I can do the same way. या फेस वरती ह्या लाईन वरती मॅक्सिमम झेड कुठला विजिबल आहे? इथे आहे. So this point will become visible. So all these surfaces points will become visible on this face. So partially visible surfaces are also detected by using Z buffer, and overlapping objects convex किंवा concave कोणतेही असेल तरी we can cater the needs. Okay, so that is the plus point of the Z buffer algorithm. Okay, so that is about Z buffer. Okay, so we will see some features of the Z buffer again. So this method requires additional buffer, right? That can be the drawback, because along with the storage of Z values, it requires the intensity buffer also. So this require additional buffer, and it is the overhead involved because it requires higher memory. So overhead is required to update that buffer every time, because whenever I am updating the Z values, the corresponding intensity values also I have to update. So that is the overhead in this process. Then the second is, so this method is less attractive in the cases where only few objects are to be rendered. So if in the scene, if I am having the objects like this is one object, the second object is over here, the third object is over here, which are non-overlapping. So if this is the case, non-overlapping objects are there, then this method is not useful, because very less number of objects are there, and that too non-overlapping. So unnecessarily I am wasting the space required for this intensity buffer. So this method is useful for overlapping objects. That is the one thing. Next is, it is simple, because simply you have to do the comparison of Z value. This method is very simple and does not require additional data structure, because just I have to compare the Z parameter. So it do not require any data structure. This Z value can be calculated incrementally. Z value we are going to calculate incrementally by keeping X and Y fixed. Z is increasing in this order towards the viewer. No object comparison is required. So whatever may be the object, maybe it is a square or maybe it is a circle. Suppose I am having one circular object placed before placed here. Suppose it is a kind of cylinder. So I don't have to judge the shape of the object. Simply I will check the maximum Z value, whatever may be the shape. So here no object comparison is made. Simply we have to check only the Z parameter. No pre-sorting of polygon is required. So here I don't have to sort the polygons according to the shape or according to the position of the polygon. I don't need any type of sorting. It can be applied to non-polygonal objects also. Examples are like this. If non-polygonal objects are there, even if the object is like this, 1/4 or quarter circle like that. So in that case also I can apply this algorithm. And the comparison time, which is as compared high, because every time I need to compare the Z coordinate of each pixel. So that comparison point or time required to do that computation is higher. And for that, the remedy is if we go for the hardware implementation of that. If we go for the hardware implementation of algorithm, then the time required will be less. So hardware implementation is also available in some graphics workstation. It is using this Z buffer algorithm. For large images, the algorithm could be applied, but for smaller images, it is not as feasible as the earlier method. Okay, so this is the other points about the Z buffer. Similarly, we will see the drawbacks, advantages, and disadvantages also. So what are the advantages? It is easy to implement because simply you have to do the comparison. It reduces the speed problem if implemented in hardware. So just now I told you the comparison requires or it is a time consuming process. So speed can be increased if we implement it with hardware. And it processes one object at a time. So actually, instead of one object, we can say it processes one line where X and Y values are same. So on this line, I am processing the Z coordinate only. So it is considered like that. And disadvantages, what can be disadvantages? Extra memory is required for storing the intensity values, and time consuming process because comparison of every pixel's Z coordinate. So these are the two drawbacks of this method. Okay. So next method is area subdivision. Or before we go for area subdivision, we will see the earlier method, Painter's algorithm, because it has the exactly opposite working as that of Z buffer. Z buffer is also working hota. So it has the exactly opposite working in the Painter's algorithm. So Painter's algorithm, why the name is given as Painter's algorithm? Because have you seen any painter drawing the image?
Yes, ma'am.
Yes. So it first concentrates on the images or the objects which are placed at the far. That means background side चे जे objects पहिल्यांदा असतात. So if I want to draw any picture of suppose mountains and trees and houses, right? Suppose I want to draw in the image, I want to draw the mountain, I want to draw tree, and I want to draw a house, right? So normally the painter starts with drawing the background images. He will first concentrate on the mountains which is at the far distance. Then it will see the tree like structure, and then it will draw the house, right? So it is a normal working of a painter. Now this algorithm works in the similar manner that it will concentrate on the background images first. आपण Z बफर मध्ये काय केलं होतं? Z बफर मध्ये आपण पहिल्यांदा कॉन्सन्ट्रेट केलं होतं जे व्ह्युअरच्या जास्त जवळ आहे, that we were concentrating on. But here the painter's algorithm is concentrating on the far objects which are having the greater distance from the viewer. those objects are considered first. So I will draw the mountains, then I will draw the tree, and then I will draw the house. So that is the way of working of a painter, and the same approach is used here, and that's why the name is given as painter's algorithm. It uses the method of depth sort. So again, it is using the Z parameter or depth parameter, and we are going to sort the objects based on the depth value. So first, it sort all the surfaces according to their distances from the viewport. So this is your viewport, or the person which is viewing with respect to the user or viewer. So it sorts all the surfaces according to the distance from the viewer, from the viewpoint. Second, it render the surfaces to the image buffer one at a time, starting from the farthest surface. So processing is carried out. Render means what? The process. So processing the surfaces can be carried out one by one, starting from the farthest surface. जे सगळ्यात लांब असेल त्या surface पासून rendering or processing चालू होईल. So surfaces close to the viewpoint will replace those which are far away. So surfaces which are closer, this is the closer surface, that will be replaced by the surface which are at far away. So exactly opposite is the thing. After all surfaces have been processed, the image buffer store the final image. So once I finish, first the farthest surfaces are processed. Then the second thing is the processes which are near, and again the processes which are more closer to the viewer. So in that respect, you are processing the surfaces, and as soon as this processing is over, then you have that image in the image buffer. After all surfaces have been processed, the image buffer stores the final image. The basic idea of this method is simple. When there are only few objects in the scene, this method can be very fast. If I am having the few objects, then it will be giving you faster output. However, as the number of objects increases, the sorting process will become complex and time consuming. Right? Obviously, if I'm having one more tree over here, then definitely it will check the depth of the first tree with the second tree. And every time I need to do the same thing. If I increase one more house over here, then again it will check for the depth of house with the second house with the earlier tree, house with this new tree. What is the depth? So as I'm increasing number of objects in the scene, then the comparison also increases, and the sorting process becomes complex and time consuming. So it has total 5 steps. This algorithm has total 5 steps. So for that, it need to check the overlapping of the objects along z-axis, the overlapping along x-axis, then the surfaces are in front or on the back side of each other. That is the third test. So accordingly, we are going to process this algorithm. So let us start the working. So first thing what we are doing is we are going to assume or we are going to have the Z direction viewing. That is, we will have the viewer along the Z axis. So assuming we are viewing along the Z axis, surface S with greatest depth. S is having the maximum depth. That means here the Z max and Z min are plotted like this, which are greater than Z dash max and Z dash min of S dash surface. So meaning is S is on the back side. S means the farthest image. जे पाठीमागे आहेत ते म्हणजे S आहे आणि S dash म्हणजे towards viewer आहे. So surface S with greatest depth compared to other surfaces in the list to determine whether there are any overlap in the depth. If no depth overlap occurs, S can be scan converted. So it will check for the overlaps. Now here the condition is S and S dash. These are the two objects in the display. There are only two objects in the display, S and S dash, where S is having the maximum Z value. Z ची value तुम्ही बघितलं तर this is Z max and Z min. And the condition is the Z min, the minimum value of S. ती कुठली आहे? Z min ही value आहे, the minimum value is also greater than maximum value of Z dash. या S dash ची maximum value काय आहे? तर Z dash max आहे. पण ह्याच्या maximum value पेक्षा पण S ची minimum value पण मोठी आहे. So Z minimum of this surface is this value. Suppose we will write some values here. Okay, so for your understanding I will write here this value origin. So Z value h is 0 है, h is Z value 1 है, h is Z value suppose 3 है, h is 5 है and इथं 10 है. That means S is having the Z max value 10 and Z min value 5. म्हणजे S surface is lying from Z5 to 10. तसं S dash is lying from Z value 1 to 3. That means आता ह्याची S ची Z min value काय आहे? 5. आणि S dash या surface ची Z max काय आहे? तर 3. Which value is greater? This value is greater. So I can say S and S dash are non-overlapping. ते overlap नाही होते. आता जर कंडिशन अशी असती की this is your S dash. आता तुमचं S dash इथे, त्याच्याऐवजी जर S dash इथे असतं तर काय झालं असतं? याची Z मॅक्सिमम S dash ची आली असती 6. ही 6 आली असती and Z min आहे 5. So 5 आणि 6 मध्ये रिलेशन काय? 6 is greater. म्हणजेच Z maximum of S dash is 6, which is greater than Z min of S. मग जर असं असेल तर मात्र ते overlapping surfaces असले असतील. Okay, so if non-overlapping are there, आता ते overlap करत नाहीत एकमेकांना, दोन्हीचेही Z पॅरामीटर टोटली वेगळे आहेत. So in that case we will process S first. पहिल्यांदा मी S प्रोसेस करणार, कारण या पेंटर अल्गोरिदम मध्ये काय, ज्याचा जो फारदेस्ट आहे, ज्याची Z व्हॅल्यू जास्त आहे, तो पहिल्यांदा मी प्रोसेस करणार आहे. सो आय विल प्रोसेस S and then I will process S dash. Okay, so this is how you are going to proceed. So first step is what? No depth overlaps. ह्याच्यामध्ये डेप्थ ओव्हरलॅप होत नाहीयेत. So depths are not overlapping. Okay, so depth are not overlapping. Then S can be scan converted. मग पहिल्यांदा मी S न प्रोसेसिंग चालू करणार आहे. This process is repeated for the next surface in the list. मग next surface साठी सुद्धा suppose S double dash असेल तर for that surface also this method is repeated. However, if depth overlap is detected, आता आपण बघितलं होतं की S आणि S dash जर अशी काढली तर त्याला depth overlap होत आहेत. So however, if depth overlap is detected, we need to make some additional comparisons to determine whether any of the surfaces should be reordered. आता ऑर्डरिंग काय आहे? पहिल्यांदा S आणि नंतर S dash ही ऑर्डर आहे. पण जर असं ओव्हरलॅप असेल then we need to go for further tests. पुढच्या टेस्ट काय आहेत? I have to check with X overlap. त्याच्यानंतर I have to check with behind and behind surfaces and front surfaces. या सगळ्या टेस्ट आहेत. सो फर्स्ट टेस्ट मी काय करतेय? ओव्हरलॅपिंग आहे की नाहीये. जर नसेल तर S पहिल्यांदा S डॅश नंतर ही ऑर्डर फिक्स आहे. बट जर ओव्हरलॅप असेल then I have to go for further tests. आणि सगळ्या टेस्ट करून पण ओव्हरलॅप सॉल्व्ह होत नसेल then I will interchange the order as S dash and then S. जर ओव्हरलॅप if overlap च्या orders change, if overlap is not, we are not able to solve the overlap issues, then we will alter the order of the operation. This is the method of working of Painter's algorithm. Okay, all of you have got up to this?
Yes, ma'am.
Okay, so जोपर्यंत ओव्हरलॅप होत नाहीये तोपर्यंत हीच ऑर्डर आहे. जेव्हा ओव्हरलॅप असेल तेव्हा आपण ते सॉल्व्ह करायचा प्रयत्न करू आणि जर नाही सॉल्व्ह झालं तर ऑर्डर चेंज करायचे. ओके, सो द फर्स्ट टेस्ट ऑफ ओव्हरलॅप इज व्हॉट? आता ते झेड शी ओव्हरलॅप आहेत. इन दिस केस एस असे आणि दिस इज युअर एस डॅश. हे दोन आहेत ते तुमचे झेड बरोबर ओव्हरलॅप आहेत. त्या केसमध्ये आय विल चेक वेदर दे आर ओव्हरलॅपिंग ऑन एक्स ऍक्सिस. हा तुमचा एक्स आहे आणि हा तुमचा झेड आहे. सो इफ दे आर नॉट ओव्हरलॅपिंग, if they are not overlapping on Z, on X, then I can continue the same order. S आणि S dash हीच सेम ऑर्डर मी फॉलो करू शकते जर त्यांचे X पण ओव्हरलॅप होत नसतील तर. फक्त Z ओव्हरलॅप आहेत but their X are not overlapping. Okay, so that is your first test. So test, what is test? Two surfaces with depth overlap but no overlap in the X direction. Along Z they overlap होत आहेत. You can check here. You can check that along Z axis they are overlapping. This is your S dash चा portion आहे हा आणि S चा portion आहे हा. So for this much portion they are overlapping. बरोबर. So they are overlapping in Z direction, but in X direction there is no overlap. Then we can still follow the same order. पहिल्यांदा S आणि नंतर S dash केलं तरी चालेल. त्याच्यानंतर थर्ड केस काय आहे? समजा त्या दोन्ही मध्ये पण ओव्हरलॅप होत आहेत. आता बघा इथे हे आहे तुमचं झेड कोऑर्डिनेट. झेड मध्ये पण त्यांचं ओव्हरलॅपिंग आहे एवढ्या पोर्शन साठी, या पोर्शन साठी. अँड I will use different color. Okay. And along X also overlapping is present. या portion साठी. Okay. So both the conditions are not satisfied. पहिली condition काय? कुठलंच overlap नाही. तर हीच ऑर्डर फॉलो करा. दुसऱ्यामध्ये Z चं ओव्हरलॅप आहे पण X चं ओव्हरलॅप नाहीये. So this condition is followed again. But now we have overlap in both the directions, Z as well as X direction. दोन्हीकडेही overlap होते. So in that case, we will check whether the surface S is completely behind. Surface S is completely behind the overlapping surface S dash. मग S dash च्या completely behind जर तो असेल, how am I going to check it is completely behind? By using the Y parameter. आता X आणि Z चा तर ओव्हरलॅप आहे. So I will check with the Y value. Y value प्रमाणे जर S हा completely behind असेल S dash च्या, then also I can proceed because आपलं मोटो काय, जो बॅक साइडला आहे तोच पहिले प्रोसेस करायचा आहे. सो S जर completely behind असेल, S is completely behind, then also we can follow the same order. S च पहिल्यांदा आणि नंतर S dash, कारण आपल्याला पाठीमागचंच ऑब्जेक्ट पहिल्यांदा प्रोसेस करायचंय. So if S is completely behind, then also we can follow the same order by checking the Y value. कळालं इथपर्यंत सगळ्यांना? Yes, students. Or shall I repeat? Am I audible?
Yes, ma'am. Ma'am, repeat please.
Okay, which portion you have not understood?
Ma'am, this example part I have not understood. All the three graphs, shall I explain again? Yes, ma'am. Okay. So see, what is the working of Painter's algorithm? Painter's algorithm काय सांगतं की जो सगळ्यात बॅक साइडला असेल ते पहिल्यांदा प्रोसेस करायचंय. पहिल्यांदा आपल्याला हिल्स ड्रॉ करायचे, देन जवळचे ऑब्जेक्ट, त्याच्यानंतर अजून जवळचे ऑब्जेक्ट जे काय असेल ते. ओके. सो what the Painter algorithm tells us, सगळ्यात बॅक साइडचे पहिल्यांदा ड्रॉ करा. बॅक साइडला आहेत हे तुम्ही कसं जज करणार आहे? डिपेंडिंग अपॉन द Z पॅरामीटर. जर Z ची व्हॅल्यू इथे तुमचे हिल्स आहेत at Z equal to 0 suppose, and again here you are having the tree at Z equal to 5, and here you are having the house like structure at Z equal to 10. मग या केसमध्ये ते ओव्हरलॅपिंग नाहीयेत एकमेकांना, कारण Z च्या व्हॅल्यू टोटली डिफरंट आहेत. Z ची व्हॅल्यू 0 आहे ह्याच्यासाठी, हिल्स साठी, Z ची व्हॅल्यू 5 इथे, Z ची व्हॅल्यू 10 इथे. ओके. सो फर्स्ट केस इज व्हेन दे आर नॉन ओव्हरलॅपिंग. हा एक सरफेस आहे, हिल्स म्हणजे तुमचा सरफेस S आहे आणि ट्री म्हणजे तुमचा सरफेस S डॅश आहे समजा. So these are the two surfaces, S and S dash. They are non-overlapping along Z. If no depth overlaps. बरोबर? Z चं ओव्हरलॅप होत नाहीये इथे कुठलंच. Then काय करायचंय? Then S can be scan converted. म्हणजे S पासून मी प्रोसेस चालू करेन. S बॅक साइडची आहे. S बॅक साइडचा सरफेस आहे. So I will start from the hills start from the surface S because there is no overlapping. कळलं आता इथपर्यंत? ही फर्स्ट कंडिशन कळाली आहे?
Yes, ma'am.
ओके. देन म्हणजेच एस आणि एस डॅशचा झेड व्हॅल्यूज एकमेकाला कुठेही इंटरसेक्ट करत नाहीत. ते टोटली झेड व्हॅल्यूज त्याच्या वेगळ्या वेगळ्याच आहेत. सो आय कॅन process them separately. I will start with S first and then I will start with S dash. हीच ऑर्डर मी फॉलो करेन. पहिल्यांदा S आणि नंतर S dash ही ऑर्डर. आता दुसरी कंडिशन आहे की समजा माझ्याकडे दोन सरफेसेस आहेत, त्यांचे झेड व्हॅल्यू आर ओव्हरलॅपिंग इच अदर. आता बघूयात, या ट्रीची डेप्थ समजा 3 पासून चालू झाली आणि 5 पर्यंत आहे. ट्रीची विड्थ और वी कॅन से डेप्थ ओनली. सो ट्रीची डेप्थ आहे 3 पासून 5 पर्यंत आणि एक दुसरा ऑब्जेक्ट आहे समजा अजून एक ट्री आहे, त्याची विड्थ आहे 4 पासून 6 पर्यंत. ओके, आय विल राईट हिअर 4 to 6. आता काय होतंय, हे ट्री ओव्हरलॅप करतायत का एकमेकांना? एक ट्री आहे 3 पासून 5 पर्यंत आणि दुसरा आहे 4 पासून 6 पर्यंत. म्हणजे 4 ते 5 हा पोर्शन जो आहे ते दोन्ही मध्ये ओव्हरलॅपिंग होतंय. बरोबर?
Yes, ma'am.
ओके, सो दिस इज द एक्झाम्पल. आता ओव्हरलॅप होत आहे, मग तुम्हाला कसं कळणार आहे की कुठला ट्री पहिल्यांदा चालू करायचा ड्रॉ करायला? हा 3 ते 5 वाला पहिला ड्रॉ करायचा का 4 ते 6 वाला पहिल्यांदा ड्रॉ करायचा? बिकॉज दे आर ओव्हरलॅपिंग अलॉंग झेड. मग त्यामध्ये काय सांगितलंय इथे बघा, हेच एक्झाम्पल आहे ज्याच्यामध्ये एस आणि एस डॅश आर ओव्हरलॅपिंग इन झेड. हा जो पोर्शन आहे हा झाला त्यांचा ओव्हरलॅपचा पोर्शन. इथे एस चालू होतंय आणि एस डॅश इथे संपतंय. म्हणजे ह्या पोर्शन मध्ये एस आणि एस डॅश दोन्ही चालू आहेत ऍट ए टाइम. मग मी एस डॅश पहिले चालू करायचं ड्रॉ करायला का एस पहिले चालू करायचं ड्रॉ करायला? मग त्याच्यासाठी सेकंड टेस्ट काय सांगितलीये त्यांनी की हाऊएव्हर इफ डेप्थ ओव्हरलॅप इज डिटेक्टेड, इथे आपल्याला डेप्थ ओव्हरलॅप मिळालं, सो ऍडिशनल कंपॅरिझन इज डन इन एक्स डायरेक्शन. तर मी त्याचे एक्स डायरेक्शन चेक करणार. एक्स मध्ये काही ओव्हरलॅप आहे का? हे ट्री या पोर्शन मध्ये आहे आणि हे ट्री टोटली दुसऱ्याच पोर्शन मध्ये आहे. त्याचं एक्स ओव्हरलॅपिंग काही आहे का? नाहीये. हा एक्स ऍक्सिस आहे तुमचा. बरोबर आहे? अलॉंग एक्स देर इज नो ओव्हरलॅप. पहिला ट्री इथं प्रेझेंट आहे आणि दुसरा ट्री या एरियात प्रेझेंट आहे. एक्स ची कुठलीही व्हॅल्यू ओव्हरलॅप होत नाहीये. ठीक आहे. Then also I will follow the same sequence. पहिल्यांदा एसच आणि नंतर एस डॅशच. मग हा समजा एस ट्री असेल तुमचा आणि हा एस डॅश असेल, तर आय विल ड्रॉ एस पहिल्यांदा अँड एस डॅश नंतर. तरी काही फरक पडणार नाही जर मी सेम ऑर्डर ठेवली तरी, कारण त्यांचं एक्स ओव्हरलॅप नाहीयेत. कळाला आता इथपर्यंत? येस.
Yes, ma'am.
ओके. आता तिसरी मेथड. आता इथे एक्स ओव्हरलॅप नव्हते, पण पुढच्या केसमध्ये एक्स पण ओव्हरलॅप आहेत आणि झेड पण ओव्हरलॅप आहेत. याचा अर्थ काय? तर माझ्याकडे आता अजून एक ट्री आहे जो इथंच प्रेझेंट आहे 4 to 6 आणि सेम एक्सच्या एरियामध्ये, हाच एरिया एक्सचाच. आता माझ्या पिक्चर मध्ये 2 ट्री अवेलेबल आहेत. गेटिंग इट? आता काय होतंय, एक्स बरोबर पण तो ओव्हरलॅप होतो आणि झेड बरोबर पण तो ओव्हरलॅप होतोय. बरोबर आहे. ह्या पोर्शन मध्ये होतोय तो झेड बरोबर ओव्हरलॅप, ह्या पोर्शन मध्ये होतोय तो एक्स बरोबर ओव्हरलॅप. आता तुम्ही कोणतं चित्र पहिल्यांदा ड्रॉ करणार, कोणता ट्री पहिले ड्रॉ करणार? सो नाव आय विल चेक कुठलं ट्री, म्हणजे समजा हा रेड कलरचा आता एस डॅश असेल आणि ब्लू कलरचा एस आहे पहिला आपला जो एस आहे तो. देन आय विल चेक एस हा टोटली बिहाइंड आहे का? एस हा ब्लू कलरचा ट्री कम्प्लिटली पाठीमागे आहे का या एस डॅशच्या? तर येस. आता हा माझा आहे ट्री तो 4 ते 6च्या दरम्यान आहे आणि हा आहे तो 3 ते 5च्या दरम्यान आहे. सो आय विल से दॅट हा टोटली जर बाहेर पाठीमागे असेल, एस डॅश सॉरी एस हा जर टोटली सरफेस एस इज कम्प्लिटली बिहाइंड, हा ब्लू कलरचा ट्री हा कम्प्लिटली बिहाइंड असेल रेड कलरच्या, तर मी आहे तोच सिक्वेन्स ठेवणार, कारण मला आधी बॅकग्राऊंडच काढायचेत ना ऑब्जेक्ट. जे लांब आहेत तेच ऑब्जेक्ट पहिल्यांदा काढायचे, म्हणून मला ब्लूच ट्री पहिल्यांदा काढावा लागेल. ठीक आहे, कळलंय आता?
Yes, ma'am.
Girls, all of you are understanding now?
Yes, ma'am.
Okay. So that is your third test. पहिली टेस्ट आहे की अजिबातच ओव्हरलॅप नाहीये, तर डायरेक्टली ड्रॉ करा एस नंतर एस डॅश. जर झेड ओव्हरलॅप आहेत पण एक्स ओव्हरलॅप नाहीयेत, तरी एस आणि एस डॅशच फॉलो करा. जर दोन्ही ओव्हरलॅप आहेत पण एस कम्प्लिटली बिहाइंड आहे, तरी पण एस आणि एस डॅशच फॉलो करा. पण आता एस जर समजा पुढे असेल, I will drop some portion. Okay. Now I will apply the fourth test. First test झाली, second झाली, third झाली. आता fourth test काय? तर fourth test आहे overlapping surface S dash is completely in front of S, but S not completely behind S dash. So what is the meaning of this statement is overlapping surface S dash, हा overlapping surface आहे S dash, red colorचा tree, which is completely in front of S. हा रेड कलरचा ट्री हा कम्प्लिटली इन फ्रंट आहे, बरोबर आहे, तो 4 ते 6च्या दरम्यान आहे. झेड व्हॅल्यू इज बिटवीन 4 to 6, सो इट इज कम्प्लिटली इन फ्रंट ऑफ एस, बट एस इज नॉट कम्प्लिटली बिहाइंड एस डॅश. म्हणजे एक्झॅक्ट तो कम्प्लिटली बिहाइंड होत नाहीये. समजा सम पोर्शन इज ओव्हरलॅपिंग अगेन, सम पोर्शन इज overlapping. So in that case, what we are going to do is, for example, the small portion of the tree is here. Okay. So you have seen that this red tree is in front, but this blue tree is not completely behind. That means some portion is visible. हा portion visible आहे. बरोबर आहे? So some portion of blue tree is invisible due to this red, but some portion is visible. मग या केस मध्ये काय करणार आहे? Still you have to follow the same order. बॅक साइडच पहिल्यांदा तुम्ही ड्रॉ करणार एस अँड एस डॅश नंतर, बिकॉज सम पोर्शन इज आउटसाइड. some portion of this blue tree is still visible. If this is the case, then also you are going to follow the same technique. That S पहिल्यांदा ड्रॉ करा, त्याच्यामधला हा ब्लू कलर विजिबल राहील आणि त्याच्या पुढे तुम्ही एस डॅश ड्रॉ केलं रेड कलरचं ट्री की the portion of the blue color will get disappeared. मग आता उरलेला तुम्हाला रेडच कलरचा ट्री दिसेल, पण फक्त स्मॉल पोर्शन विच इज नॉट कम्प्लिटली बिहाइंड. नॉट कम्प्लिटली बिहाइंड. जो पोर्शन कम्प्लिटली बिहाइंड नव्हता या रेड ट्रीच्या तेवढाच फक्त विजिबल होईल. सो आय कॅन फॉलो स्टील द सेम ऑर्डर टू डील विथ दिस कंडिशन ऑल्सो. अर्लियर कंडिशन मध्ये काय होतं, एक ब्लू कलरचा ट्री होता आणि त्याच्याच पुढे एक रेड कलरचा ट्री होता. असा त्याच्या पुढे रेड कलरचा ट्री होता. सो कम्प्लिटली इन फ्रंट होता आणि हा कम्प्लिटली बॅक साइड होता. सो आय कॅन ड्रॉ द ब्लू फर्स्ट अँड देन रेड, नो इश्यूज. But second condition is now I am having the surface S dash and I am having the surface S. Okay, only this much portion. Okay, so what is there? If I am viewing this, what it tells, the overlapping surface S dash is completely in front. S dash ha full front मध्येच आहे, but S is not completely behind. ह्याच्यामध्ये काय होतं, blue surface completely behind होता, काहीच दिसत नव्हतं. But here some portion of the blue is visible, so it is not completely behind. And that is the way of drawing the object. So I will draw this tree first. Still I can draw the S first and then S dash. Okay, so still I can follow the same method. S आधी draw करणार आहे and then I will follow, I will draw the S dash, then I will get the same image. Then next condition, what it tells, surface S has greater depth but obscures surface S dash. Surface S has great depth but it obscures surface S dash. Meaning is it now S dash is totally behind. Now S dash is totally behind. So what I can do is it completely obscures. So in that case also I will draw first S only. And there is no need to draw S dash now. Surface S has greater depth, but it totally obscures surface S dash. So if it is the example, then I can draw, then also I can have the same sequence of drawing it. S followed by S dash. But now if this portion is totally not visible, if this total portion is not visible, that means now S dash is completely behind S. So here the blue tree is in front and the red tree is behind. The red tree is behind the blue tree. Though they are overlapping in X direction, they are overlapping in X direction, obviously. The X value of this and X value of blue tree, they are overlapping. Similarly, the Z value is also overlapping. Z value is in between 3 to 5 and 4 to 6 again. Then also it is overlapping, but it completely obscures the surface S dash. Then is there any meaning of drawing S and then S dash? मग तेव्हा काय होईल, मी आधी S ड्रॉ केला म्हणजे ब्लू ट्री ड्रॉ केला आणि त्याच्यानंतर जर मी रेड ट्री ड्रॉ केला तर दॅट रेड ट्री विल बी विजिबल. Right, but it should not happen because this S dash is at the back and S dash is completely obscured by the S. So in that case, I should alter the order, and that is the final case, that is S dash first followed by S, because now S dash is on the back side. And our painter algorithm. So what the painter algorithm tells us, the background image should be drawn first, and that is why I will draw this red color tree first, and then I will draw the blue color tree. So what will happen? Ultimately, only the blue color tree will be visible as I have changed the order. And that is what it is called as the last step of this algorithm. Okay, so this is done for the 2 surfaces. If 3 surfaces are there, then according to their sorted values, you can reorder the first. We are having the order as S, S dash, and then S double dash, and you can reorder according to these cases by applying these cases, and the reordering can be done as S dash, S double dash, and then S. So in the same manner. Getting it, all of you?
Yes, ma'am.
Okay. So that is how the painter algorithm works. So depth sorting method uses both image space and object space operations. The depth sorting method performs 2 basic functions. Surfaces are sorted in the decreasing depth order. Then second, the surfaces are scan converted in order starting with the greatest depth. So the backside images are first scan converted or processed. The scan conversion is performed in image space. So remember, this method is having both object plus image space techniques. So you can see here, it uses both image space and object space operations. Because the surfaces are sorted according to their depth, which is the physical coordinate system. And it is drawn in the image using the image coordinate systems. So it uses both the approaches. So this is the one of the MCQ, important MCQ, that depth or sorting uses object space method or image space method or both. So it uses both the methods. Okay, the algorithm begins with sorting by depth. For example, the initial depth estimates the polygon may be taken to be the closest Z value of the vertex of the polygon. So it is using the same tests. So X overlap, Y overlap, and all those things. So we have already covered it with using the diagrams. Okay. So that the third algorithm that we have covered is Painter's algorithm. So the next algorithm that we will see, the last algorithm, that is the Warnock algorithm, or it is also called as area subdivision algorithm. So the name itself suggests area subdivision. So the whole screen, this area, we are going to subdivide into 4 parts every time. So here we are going to divide this into 4 parts. Okay. And every time each subpart is again subdivided into 4 parts. So this process is continued till we get the required things. So what are the required things that we will see? So let us read the information about the area subdivision. This method was invented by John Warnock and also called as Warnock algorithm. It is based on a divide and conquer method. So we are going to divide the screen every time, and that's why division. And again, we are going to conquer. So that is called as divide and conquer. It uses the fundamental of area coherence. So this is very important question as far as MCQs are concerned. This Warnock algorithm uses area coherence method. It is used to resolve the visibility of the algorithm. It classifies polygon in 2 cases, trivial and non-trivial. So trivial cases are easily handled. Non-trivial cases are divided into 4 equal sub-windows. So every time the division is made to check whether we have reached to trivial case. One second. Okay, so in this areas subdivision algorithm, we are going to find out whether we have reached the trivial case or non-trivial case. So if trivial case is reached, no further subdivision is required. But if it is a non-trivial case, then again we are going to subdivide the screen into 4 parts. The windows are again further subdivided using recursion until all polygon classified trivial and non-trivial. So every time we are going to divide it, trivial means they should be non-overlapping. For example, if on the screen I am having 2 polygons which are overlapping. Okay, 2 polygons which are overlapping. So this blue color is placed above the red color rectangle. Blue color rectangle is placed above the red color rectangle. Okay, that means the whole rectangle which is visible is blue color rectangle. The portion of red rectangle is behind this blue color. The portion which is not visible, हा portion hidden आहे red rectangle चा due to this blue rectangle. Okay, so this is the picture. Now what I am going to do is I will be dividing the screen into 4 parts. So first subdivision is done here. Okay, first subdivision is done here. Now whenever I am subdividing, now each part I will check whether I have reached the trivial or non-trivial. So this is your, suppose first part, first subdivision, and I will say first A. Then I will say first B. This is your first C part, and this is your first D part. Okay, so I will check whether first A is reached to trivial or non-trivial. First B is also reached to non-trivial or trivial. Similarly, C and D part also. Now, what is trivial and non-trivial? The portion should be the portion should be either of one color. That means in that window, I should get only one color. So here is it case. In 1A, I am having blue color as well as red color. Similarly, in 1B, similar for 1C, similar for 1D. That means I have reached to non-trivial case. So I have to subdivide it again. So subdivide it into 4 equal parts again. Now I have divided into 4 equal parts. So I have got here 2B, second subdivision, 2B, 2C, 2A, 2B, 2C, and 2D. Now out of these 4 portions, 2A, 2B, and 2D, they are of background color. So as picture color is not there, further subdivision is not required. That means I have reached to trivial case. So these 3 are the trivial cases, while 2C is still a non-trivial case. All of you are getting it? Yes. Two C is still non-trivial, and that's why I need to subdivide it again. परत एकदा मी 2C सबडिवाइड केलेलं आहे. त्याच्यामध्ये मिळालेलं आहे मला 3A, 3B, 3C, 3D. Now you tell me which windows are trivial and which are non-trivial. So 3A, 3B, 3C, and 3D. Out of that, 3D has only one color, blue color. So there is no need to further subdivide it. Then this is of background color, no need to subdivide. This is only having red color, so no need to subdivide. But this 3C is having a combination of red and blue. So again, I need to subdivide them. Getting it? So this subdivision is recursive in nature till we get the trivial portions as output. Understood, all of you? Yes,
Yes,
students? Okay. And that's why the name is given as area subdivision, because we are dividing the area into 4 equal parts always. Okay. So after subdivision, in order to check whether we have reached to trivial or non-trivial, there are 4 checks available. So what are those 4 checks that we will see? So these 4 checks are inside surface, outside surface, overlapping surface, and second overlapping surface. That also I will tell you what is the meaning of, what is the difference between these two. Okay. So inside surface means what? It is the surface which is completely inside the surrounding window or specified boundary.
So consider here 4 cases. Okay, so inside surface means what? It is the surface which is completely inside the surrounding window. Completely inside the surrounding window. So this is the surrounding window. And suppose the surface is drawn with the red color. So it is the object specified, and this gives you the boundary of the sub window. So that is 1A, 1B, 1C, and 1D. If this is your 1A, 1B, 1C, 1D, that is the sub window is a rectangle and triangle is your object. So if your object is completely inside the sub window, then this case is called as inside surface. Then second is the polygon surface is completely outside the window. The polygon surface is completely outside. This polygon surface is completely outside the window. Then it is called as outside surface, or it is also called as disjoint, because there is no connection between the object. For example, this portion. This is your window and this is your object. So object has nothing to do with the window. So this is called as completely outside or disjoint. Okay. While 2C window is having the portion which is inside. 2C मध्येच पूर्ण हा portion inside आहे. So it is called as inside. The third is overlapping surface. Overlapping means what? Polygon surface which completely encloses the window. The polygon surface this is your polygon, and inside the polygon the whole window is placed. For example, you can take this small portion. This window is completely inside your polygon. That is called as overlapping. So object is bigger and your sub window is smaller. So that is called as overlapping test 1. And second is the surface is partially inside, partially outside. So window is having the intersecting edge. So this is called as contained. That means the polygon contain the window, or the window is contained within the polygon. So that is a contained case, and this is called as intersecting. That is, some portion is inside, some portion is outside. So intersecting condition. This is outside is also called as disjoint. And the first test was inside test. Okay, so these are the 4 possibilities. विंडोच्या आतमध्ये पूर्ण ऑब्जेक्ट असेल किंवा ऑब्जेक्टच्या आतमध्ये पूर्ण विंडो असेल. So it is called as inside. This is called as contained. Completely outside असेल, which is called as disjoint, or intersecting असेल, which is called as intersecting or overlapping surfaces. Getting the 4 types. So every time subdivision झाल्यानंतर या 4 पैकी कुठली तरी एक केस तयार होईल. सो फर्स्ट सबडिव्हिजनला काय होतं इथे? फर्स्ट सबडिव्हिजनला हा आहे तो डिसजॉइंट आहे पूर्ण. तसंच हा पण पूर्ण डिसजॉइंट आहे, हा पण पूर्ण डिसजॉइंट आहे ऑब्जेक्टशी. सो आय विल कीप देम विथ बॅकग्राऊंड कलर. सो ऑलवेज रिमेंबर, जेव्हा डिसजॉइंट असेल किंवा आउटसाइड असेल तेव्हा तुमचा तो कायम बॅकग्राऊंड कलर असणार आहे.
त्या विंडोला. So which color you have to give to the window? The background color. Second, if totally contained असेल, for example, a small portion, are totally inside the blue येत असेल, completely inside the blue object, then which color you are going to give to this window? The blue color only, that is picture color. जो ऑब्जेक्टचा असेल कलर या ट्रायंगलच्या आतच आहे पूर्ण तुमचं रेक्टँग्युलर विंडो किंवा एरिया, window area. So whole window area will be assigned the picture color. Getting? Then third and fourth case. या दोन केस मध्ये मात्र काय करावं लागेल तुम्हाला? These are the trivial cases, non-trivial cases. So go on subdividing it till you get the either contained or completely disjoint. So I will divide this area into 4. मग आता मला काय मिळालं? हे दोन्ही एरिया हे डिसजॉइंट आहेत या ट्रायंगल्सची. सो आय विल गिव्ह द बॅकग्राऊंड कलर टू देम. And these two are still non-trivial. परत मी सबडिव्हाइड करणार आहे. आता काय मिळतंय मला? ह्या दोन विंडोज आहेत ह्या कम्प्लिटली इनसाइड आहेत. Windows are completely inside the object, so I will give them picture color. आणि ह्या दोन मी सबडिव्हाइड करत जाणार. Okay, so this is how you are going to draw the object which is with respect to the area subdivision method, and the technique used is area coherence. Okay, so here it is shown like this. This is your window, this is your object. So if object, this method is called as intersecting, this is called as disjoint or outside, then this is called as inside and contained. Okay, getting it?
Yes, ma'am.
Okay, now one more question is asked on this Warnock algorithm is quad or oct tree structure. So quad means 4 and oct means 8. So if a plane is divided into 4 parts, this is your plane, and plane is divided into 4 parts every time, 1A, 1B, 1C, 1D. Then a structure तयार होईल, that is called as your quad tree structure. So the complete window I will write as W. This W is divided into 4 parts. Name is 1A, 1B, 1C and 1D. And 1A कुठून चालू होतं, त्याचा lower left coordinate is going to be there. So lower left coordinate suppose 0, 0 पासून 1A चालू झालं असेल, and width of this, width समजा 10 असेल, आणि name of that is 1A. So this is one part of the window. The second part will start at lower left corner. हाताचा lower left corner आहे 1B चा. आता हे width 10 आहे, so it has the coordinates 10, 0. width त्याची परत 10च आहे आणि त्याचं नाव आहे 1B. So every time the window is divided into a 4 value format, which is called as quad tree structure, if it is a plane. And if it is a 3D object, then you are going to subdivide it into 8 subparts, 0, 1, 2, 3, like this. And at the back side, 4, 5, 6 and 7. So total 8 parts are forming
So from main window, you are going to subdivide it into 8 parts. 0 to 7 means 8 parts. Okay, and that is what it is called as subdivision, and it is called as octree structure, because eight windows are getting created. Here, in case of plane, only 4 windows are getting created. Okay, is it clear?
Yes, ma'am.
Okay. So these are the 4 algorithms how to deal with the visible and hidden surfaces that we have learned. And now the last point of this chapter is anti-aliasing and half-toning. So what is the meaning of anti-aliasing? So I will give the overview. This is the theory part. You can go through it. I will give only the overview, and I will give you the link of the regular second year students where I have covered this part. So you can go through that link if you are not understanding. So we will cover it very fast. So in anti-aliasing and half-toning, simply while drawing the raster images, raster image means what? Pixel by pixel plotting. So if I am drawing any image, any raster image, what is happening? This is the pixel I am getting selected. This is the pixel, second pixel if I want to draw a line. This is the third pixel, this is the fourth pixel. So though I am selecting the pixels, it is appearing like a staircase. Right? हे तुम्हाला picture असं दिसतंय. So this effect of staircase is called as aliasing effect. Right? Aliasing means what? The aliasing effect is the appearance of jagged edges. Jag means zigzag edges or jaggies in a rasterized image. The problem of jagged edges occurs due to distortion of the image when scan conversion is done, because we are sampling it with low frequency, which is called as undersampling. So this aliasing takes place due to undersampling, and to remove these effects and to get the straight line instead of the jagged edges, this method is called as anti-aliasing. So aliasing means this jagged image. Removing this jagged image is called as anti-aliasing technique. So this can be achieved by improving the frequency to the Nyquist sampling frequency, which is 2 into f of f max. So whatever the maximum frequency is there, into 2 should be the sampling frequency rate. Then I will not be getting this kind of staircase effect. So here we are having the formula. The time and frequency formula is time is 1 upon frequency. So similarly, we can write in terms of time also. Then to perform this anti-aliasing, we are having the 4 methods. First is high resolution display should be used. High resolution display ni काय होईल? Earlier image चे number of pixels वाढले की काय होते बघूयात आपण. आधीची इमेज कशी दिसत होती? अशी line display होत होती. Now if I will increase the number of pixels, resolution वाढवतीये म्हणजे मी काय करतेय? Number of pixels पण वाढवते. So if I am going to improve the number of pixels, now as compared to the previous, आधी कसं दिसत होतं तुमचं ऑब्जेक्ट, हा एक ब्लॉक दिसत होता, हा एक दिसत होता, त्याच्यानंतर this one and this one. This was the output for a line. अशी तुमची लाईन दिसत होती आधी ड्यू टू लो रिझोल्युशन. आता काय होईल, आता मी ब्लू कलर वापरते, ब्लू कलरने मी लाईन ड्रॉ करते. So whatever the thickness of the pixel I am getting, that has become less, and that's why the edges, that is the staircase effect, is minimized. So as number of pixels are increased, they become closer to each other, and that's why the staircase effect will be removed. So that is the use of high resolution display. Okay, that is the first approach that you can reduce the aliasing effect. Then post filtering is the second method. In that, here we are increasing the sampling resolution by treating the screen as if made of more fine grid. So here, not actually we are increasing the resolution, but we are making it as if it is of a high resolution. Screen resolution remains same, but we are going to reduce the size of the pixel. So if it is done, then we are going to get the more straight kind of line. So that is done in the super sampling, or it is also called as post filtering. So here actually we are not increasing the resolution, but we are reducing the pixel size so as to get the straight line instead of the staircase line. And the use of this is given over here. The graphics card companies like NVIDIA and AMD, they are making use of this method of post filtering or super sampling. Then pre-filtering is done in this way, that is the portion which is covering the maximum area is given the dark color, and the lesser area is given the faint color. So that is nothing but the intensity. If any pixel, suppose this is the straight line I want to draw, and in that straight line I am getting the pixels like this. Okay, so here if I observe the portion of pixel covered by the line, so if you consider this pixel, the amount of line is covering more than 70% of the pixel. Pixelची size पैकी 70% size is occupied by the line. So in that case, this pixel is given the intensity of that line, which is 70%. So this pixel will be 70% blue. But if I am considering this pixel, it has only small portion of the line which is passing through. So consider only 5%. So I will give the 5% intensity of blue color to this pixel, so that it will look like a background pixel only. And here, as the more intensity is given to this pixel will look like a picture color, which is nothing but your line color. So depending upon the overlapping extent. So The intensities are calculated proportional to the areas of overlap. So if overlapping area is more, the more amount of what we can say, the intensity will be more provided to that pixel. So it is done, which is called as pre-filtering or area sampling, and it is done before displaying the image. Before displaying, rather, before generating the raster image. And then pixel facing is the fourth technique. So here we are going to allow the size of the individual pixel to adjust according to the intensities. So if we are going to change the size of the pixels, then accordingly it will change. So here the size of the pixel will be more greater one because the intensity is greater. Here the size of the pixel will be less as the intensity is less. So according to the pixel facing is done in the in order to remove the aliasing effect. So these are the 4 ways how the aliasing effect can be minimized. Now some other techniques are also given, like we can compensate for the line intensity differences. So you can just read those things and you will get the concepts. Then half toning is the thing which is used in the newspapers, basically. So in newspapers, the photographs are drawn, or the photographs are generated according to the pixel intensities. So intensities are arranged according to the size of the pixel, like pixel phasing. Larger pixels, larger intensity is having large size. Similarly, in half toning also, with variety of dots, the number of dots are playing the important role in the half toning. So I will show you one picture and you will come to know about it. So here in this, the size of the pixel is changing. Here only the black and white dots are there. So simply I am making use of 2 dots. Size of the dot is varying. Here black color dot is larger. And according to the dots, only 2 colors, black and white, are used, and I am able to get the different shades also. So if you are observing the face here, the face is of different shade than that of the dress. And that is nothing but it is, though we are using only 2 colors, black and white, then also we are able to find the different shades of black and white. And that is achieved only by arranging the dots in a different manner. So here the arrangement of the dots are different than that of these pictures. So simply changing the dot size will change the clarity of the picture. So this technique is used in the newspapers, which is called as half toning. So let us read about the half toning quickly. So newspaper photographs simulate a grayscale despite the fact that they have been printed using only black ink. So only black ink is used for that, but it gives you a scale of gray color. That is gray shades. It will give multiple gray shades, even though we are using only black inks. A newspaper picture is in fact made up of pattern of tiny black dots of varying size. So we are changing the size of the dots and then we are getting the different shades. The human visual system has a tendency to average brightness of small dots. Our visual tendency, how we treating them, we are making the average of the small areas so that black dots and their white background merge and we get the intermediate shades of gray color. The process of generating a binary pattern of black and white dots from an image is termed as half toning. So this is the traditional technique used in newspapers and magazine, which is giving a half-tone screen. This screen is a glass plate with grid etched on it. and different screens have different size and shape of the dots. A fine grid with screen frequency 200 to 300 lines per inch, which is used for magazine production, because magazine has more finer images than that of newspapers, and that's why the frequency is more, that is 200 to 300 lines per inch. And for newspaper, only 85 lines are sufficient, because the quality of the picture is not that fine as that of magazine. So patterning is by using the different patterns, we can change the intensity. Suppose 9 by 9 block is there. If no black pixel is used, that means we are considering the background white only. If full black is there, that means we are having intensity equal to black for that pixel. So by varying the number of blocks here out of 9, we may vary the intensity. So simply you can check how the patterning make a difference in the image. And dithering its concept is nothing but our vision. So even though it is a combination of red and yellow squares, as a whole we are observing it as a orange color, though it is a combination of actually red and yellow, but our vision is combining the average or doing the average of those colors, and the whole screen is acting as a orange for us. So that is the concept of dithering. So one 2 by 2 object is written, and we are taking the average of that. So 0 means 32 is added in every field of this dither. So you can observe 32 is added in every field, and a common average is taken over here, which is called as dither matrix. So it is a 4 by 4 matrix. Similarly, you can have 8 by 8 matrix also. So by taking the different thresholds, we can have the change in the vision. Okay, so this ends with the chapter number 5. So I will send you these PPTs as well as for this last part. If you need more explanation, then I will forward the regular SY lecture recording to you also. So on your channel, I will send the link also for the regular SY class for this particular anti-aliasing and half-tone. Okay. So today we are ending with the syllabus. Already the space curves and plane curves we have covered with the guest lecture. So I will share the PPTs for that also, plane curves and space curves. Okay. So this ends with the syllabus. If you have any doubts, you can ask through WhatsApp or through mail also. So if you have any doubts right now, you can ask, or else we will stop. Is there any doubt?
No, ma'am.
Okay. Boys side?
No, ma'am.
Okay. So let us stop for today. If you have any doubts, you can ask me personally on WhatsApp also. Thank you. I will stop now. You can leave.
Okay, ma'am.